In this video, we talk about determining the interest rate swap rate via forward rates instead of via spot rates. So please pause the video, copy the material down in your notes, and then start it back up again. All right, so the idea is to determine the swap rate C via forward rates instead of via spot rates. So recall that at time zero, the market has determined the spot rate. So how much to pay the annual effective rate for a 2-year loan, a 3-year loan, a 4-year loan, or a 2-year bond, a 1-year bond with no coupons. Okay. A forward rate is also determined at time zero. And the forward rate, denoted F sub M minus 1, is the rate that will be in effect from time M minus 1 years to time M years, and only in effect for that stretch of time. So at time zero, it's the rate that we expect will move money from time M minus 1 to time M. Okay? So we're going to assume at time zero for this interest rate swap, we're going to assume for pricing purposes that the floating coupon rate paid out at time M years is given by F sub M minus 1. So this is our best bet at time zero for what the interest rate will be during the M coupon period, which we then use to determine the coupon rate for the floating rate bond. All right. Okay, so at time t equals 0, we're going to set the fixed rate bond price equal to the float rate bond price, because if you recall, that's one of the assumptions about interest rate swap. The two bonds at time 0 have the same value, same price. So the fixed rate bond price is based on the swap rate, which we don't know, but it's C. So each coupon is face value times C. And then I'm just dragging them all back to time 0, including the redemption payment, with the spot rates that we see at time 0. Now, the floating rate bond price is again the face value times the forward rate that's in effect during that coupon period. So F sub 0 moves money from time 0 to time 1 year. That's the rate we'll use for the first coupon. By the way, it coincides with the spot rate, the 1-year spot rate, and so on. The second coupon will be, the coupon rate will be based on the forward rate in effect from time 1 to time 2 during that second coupon period. So there's the second coupon, drag back 2 periods. There's the nth coupon, drag back n periods, and there's the redemption value. Now I'm going to solve for C. Okay, I'm not showing the algebra much, but FVN cancels on both of them. I can then divide everything by F, capital F, the face value. And on the left, I can factor a C out in front, and all I'm left with is the line you see there. And then I can divide the sum of the powers and the spot rates underneath the right-hand side to come up with this lovely formula, all based basically upon forward rates. Now you might say, well, hey, look, I see spot rates, V spot. Great. You do. So the V is dragging money back the appropriate number of years. If we know all of our forward rates, we can use those forward rates to drag money back the appropriate number of years. So if I had, as an outer aside, V spot 2, that's going to drag money back 2 years. Let's say from time 2 to time 0, I could accomplish that by dragging money back 1 year using the forward rate that takes money from time 1 to time 2. So divided by 1 plus that forward rate takes the money from time 2 back to time 1. And then to take the money from time 1 back to time 0, I can divide by 1 plus F0, the forward rate in effect from time 0 to time 1. Okay. So even though it says spot rates there for the V, I can accomplish the same movement of money via those forward rates. Okay. All right, so we have another way of calculating our interest for swap rate C using forward rates, this time instead of spot rates. All right, so let's go back to this example that was presented in an earlier video. I'm looking at a 3-year annual coupon swap, and I'm given the following spot rate information at time 0 concerning a 1-year, 2-year, 3-year, 0 coupon bond yield. Okay. I'm going to do this using forward rates. With previous videos, we did it using spot rates, but let's just see how to do it using forward rates. So then, again, here's my reminder of what my forward rates are doing, F0, F1, and F2. and they need to find those 3 forward rates. All right. So F0 is the same as the 1-year spot rate. I was told it was 3%. To find F1, just a little review here. To find F1, I'm going to pretend to move money from time 0 to time 2. And I can do that in 2 different ways. On the right, I'm going to move the money forward to time 2 using the 2-year spot rate. So 1 plus S of 2 squared. On the left, I'm going to move it forward 1 year with the 1-year spot rate, 1 plus S of 1. And then from time 1 to time 2 with the 1 year, the F1, the 1-year forward rate. So that both sides moves money from time 0 to time 2. I can solve for F1, throw in my spot rate information from the table that I was given, and I get that F sub 1 is 5.001%. Similarly, to get the F sub 2, I can move money from time 0 to time 3 using a 3-year spot rate, or I could move it to time 2 first using the 2-year spot rate, and then from time 2 to time 3 using F sub 2, the 2-year forward rate, or the forward rate in effect from time 2 to time 3. All right, I solve for F2. I plug in my spot rate information from my table, and I get a forward rate of 7.029%. So now I can calculate C using those forward rates. There's the formula. F sub 0 was 0.03, F sub 1 was 0.05001, F sub 2 was 0.07029, and there's my spot rates in the denominator. But I'm only presented spot rate information. I could have used this approach to replacing V with forward rate information. Okay. So I get that monstrosity, divide by my powers of V, and I get a C value, a swap rate of 4.935%, which you'll recall from earlier videos is the exact same answer we got via the spot rate approach. So if the problem gives you spot rates, you should be able to calculate C. And if the problem gives you forward rates, you should be able to calculate C.